Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Okay, let's continue our lecture with example 1 for subtopic 2.3 Gauss theorem. Okay, verify Gauss theorem for vector field f equal to 4x plus 3y plus zk where the region is bounded by between z equal to 0 and 6 and x squared plus y squared equal to 9 with outward orientation. Okay. First step, you need to sketch the region. So you sketch x, y, z. So this is z equal to 0. This is z equal to 6. So you get a cylinder. Okay, as you can see here, this cylinder has three surfaces. Okay, the bottom, the top, and the body of the cylinder. So I will label the bottom S1. Okay, the top S2 and the body is S3. Okay, next we look at the equation. Okay, the equation asks you to verify. So to verify the Gauss theorem, we need to show both sides. So we have to show left hand side and right hand side. Okay, let's start with left hand side. Okay, remember step to solve surface integral. Okay, here to find double integral for f dot ds for cylinder, okay, we need to double integrate each part of the surface. So here double integral f dot ds for s1 plus double integral f dot ds for s2 plus double integral f dot ds for s3. Okay, we need to double integrate each part of the surface. Okay, let's start with s1. Okay, s1 here z equal to 0. Okay, remember the step to find surface integral. Okay, first step we need to find n. So n here is z here is circle. S1 is a circle, so it is non-parametric surface. So to find n, you need to refer to table 2.4 in your textbook. So you can see here, unit novel vector here is pointing downwards. So you need to refer to this column. So n here is equal to 0, 0, negative 1. Okay. Step number 2, you need to calculate f dot n. Okay, f here is equal to, I will continue here. Okay, f dot n, f is 4x, 3y, z dot n here is 0, 0, negative 1. Okay, when you solve this double dot product, you will get negative z. Okay, z here is equal to 0. So f dot n is equal to 0. Therefore, double integrate f dot ds for s1 is equal to 0. Okay, I will continue in the next slide. Okay, next we find for S2. So S2 here is z equal to 6. Okay, same step. You need to find n. So z equal to 6. S2 is also a circle. So you need to refer to table 2.4 to find the n. So for this S2, you can see here, the unit normal vector is pointing upwards, so it is from positive orientation, so you can refer to this column. So you get n here is equal to 0, 0, 1. Okay, step number 2, you need to calculate f dot n. So f here is 4x 3y z dot 0 0 1. When you solve this dot product, you will get z. So z here is equal to 6. So f dot n is equal to 6. Okay, step number 3. Okay, you can substitute in the double integral formula. F dot n is equal to 6 ds. So ds here you can refer to polar coordinate of plane. So you will get ds here is 6 r dr d theta. Okay, step number 4, you need to find limit of integration. Okay, first you need to integrate respect to dr. So r here is equal to 3. You can find r from here. R equal to 3. So from 0 to 3. Okay, for d theta, okay, this is a full circle. So full circle 0 to 2 pi. Okay, step number 5, you solve the integration. So here you integrate respect to dr, you will get 6r squared over 2 0 to 3 d theta. Substitute 3 and 0, you will get 27 d theta. So integrate respect to theta, you will get 27 theta 0 to 2 pi. Substitute 2 pi and 0, you will get 54 pi. Okay, next we want to find S3. Okay, S3 here is x squared plus y squared equal to 9. Okay, cylinder is a parametric surface. Okay, to find n, you can use formula del S over magnitude of del S. So here del S is equal to 2x 2y0 over magnitude of del S is 2x squared plus 2y squared plus 0 squared. Okay, when you solve it, you will get 1 over 3x y 0. Okay, step number 2, you need to calculate f dot n. So f here is 4x 3y z dot 1 over 3x y 0. Okay, when you solve this dot product, you will get 1 over 3 4x squared plus 3y squared. Okay, you can simplify it. You will get 4 over 3 x squared plus y squared. Okay, next step number 3. Okay, because this is a cylinder, you need to convert to polar coordinate of cylinder. So polar coordinate of cylinder, x equal to r cos theta, y equal to r sin theta, z equal to z ds is equal to r d theta dz. So when you substitute in double integral for S3, okay, f dot n is equal to 4 over 3 r cos theta squared plus r sin theta squared. Okay, ds is r d theta dz. So when you simplify it, you will get double integral S3 36 cos squared theta plus 27 sin squared theta d theta dz. I will continue in next slide. Okay, step number 4, we need to find the limit of integration. So theta here is equal to 0 to 2 pi because full circle, and for z is 0 to 6. So you can solve the integration. You can replace cos squared theta and sin squared theta with this one. So you will get here 36 1 plus cos 2 theta over 2 plus 27 1 minus cos 2 theta over 2 d theta dz. So when you integrate respect to d theta, you will get 36 theta over 2 plus sine 2 theta over 4 plus 27 theta over 2 minus sine 2 theta over 4 0 to 2 pi dz. Okay, when you substitute 2 theta and 0, you will get 63 pi dz. Okay, next integrate respect to dz, you will get 63 pi z 0 to 6. Okay, when you substitute 6 and 0 in z, you will get 378 pi. We have find S1, S2 and S3, so we just add up. S1 is equal to 0 plus S2 54 pi plus S3 378 pi. So you will add up, you will get 432 pi. So this is left hand side. Okay, I will continue for right hand side in the next slide. Okay, next for right hand side, triple integral div f dv. Okay, remember what you have learned in del operator, div f, or you can write del dot f. So del x, del y, del z dot f is for x, 3y, z. You solve the dot product, you will get 4 plus 3 plus 1 equal to 8. So, we substitute in triple integral div f equal to 8 dv. Okay, you use polar coordinate of cylinder, so dv is r dr d theta dz. Okay, now we want to find the limit of integration. So first you need to integrate respect to r. So r is 3. Here r is equal to 3. So integrate from 0 to 3. Okay, for theta, full circle. So from 0 to 2 pi, and z is 0 to 6. Okay, so this is the limit for integration. So I will continue the integration in the next slide. Okay, first we integrate respect to dr. So you will get 8r squared over 2 d theta dz. You substitute 3 and 0, you will get 36 d theta dz. Now integrate respect to d theta, you will get 36 theta 0 to 2 pi dz. Substitute 0 and 2 theta, you will get 72 pi
dz, and lastly integrate respect to dz, we will get 72 pi z. Substitute 0 and 6, we will get 432 pi. So now we have verified left hand side equal to right hand side. So Gauss theorem is verified. So I think that's all for this video. Thank you.